Black holes. What's really inside? The universe, far beyond our world, is loaded with objects so strange and wonderful that it's hard to believe that they occur. Perhaps the oddest of them all are black holes. Bottomless pits that devour stars, drive galaxy centers, and warp space and time. If you come too close, the totality of time may pass you by, and there is no escape. Black holes are mystical objects. They are remarkable frameworks of space-time from which nothing can exist, not even light. Physicists can predict everything that occurs in the cosmos beyond the black holes. We would like to know what's going on in the center of it, where the matter collapses into the black hole. At this point, we can't implement Einstein's theory of relativity. It collapses. And so, that poses some basic queries. Welcome to Brainbender's Solarium. Join us as we explore black holes and what's really inside them. The complexities of black holes, which are puzzling and unresolved, are the nature of their singularity. What happens when the curvature of time and space drift inside a black hole? Is it a channel, a route to another universe? Is there space where the matter is collected? According to Einstein's gravity, the singularity is gathered by it, and so a paradox emerges. Modern physics is characterized by two primary theories: general relativity and quantum mechanics. Generally speaking, these ideas do not contradict each other. According to relativity, black holes generate a singularity, a point in spacetime with an infinite density. And according to quantum mechanics, it's unlikely. Black holes could hold the secret of reconciling these two theories to a unified understanding of physics. We need to push boundaries to explore the universe, and the best areas to push limits are severe circumstances in extreme environments. And the most extreme environments we know in the universe are black holes, since they represent locations where space and time themselves have a fracture, a pathological behavior that leads to paradoxes within physics. Black holes don't emit light, they're black, but the matter surrounding them absorbs light when it heats up, so some of this light can be absorbed by the black hole as it arrives from behind. That light appears as a silhouette, a dark part of the picture that reflects the area around the black hole from which light cannot escape. To produce an image of the event horizon, researchers worldwide have worked together to construct an event horizon telescope, an array of telescopes as large as our entire planet. The Black Hole Initiative helps process data, leading to the first direct observation of the black hole. The questions posed by the black holes encourages collaboration amongst a wide range of disciplines: plasma scientists, philosophers, physicists, astronomers, computer data specialists, and filmmakers. Physics has reached a point where a new hypothesis has to be considered. And in thinking about the new theory, philosophical ideas are incredibly relevant since they give us a broader perspective. It has become an intellectual sky where we could have philosophers communicating to physicists. People coming from different backgrounds have a better chance of cracking a problem. So, what occurs inside a black hole? If you were brave or naive enough to go into a black hole, what would happen when you passed the event horizon? First of all, there would be physical effects on the body. Spaghettification is expected to happen sooner for stellar black holes than for supermassive black holes. Another theory is that when travelers pass the event horizon, they will reach a superheated wall of energy known as a firewall that would keep them from going any further. Scientists developed the concept of a firewall to overcome a problem emerging from our current knowledge of black holes, known as the black hole information paradox. But not all researchers are persuaded of a firewall concept, and it's unlikely that we'll ever know if it's valid. At least, not until we resolve some of the gaps between general relativity and quantum mechanics. So we know what might happen to your body, but what will happen with the passage of time? As explained above, we know that, relative to other people sitting far away, time will run at a different pace as you get closer to a black hole. Based on our current understanding of physics, we think that things will get strange on the event horizon and that you might even be able to see time going by. Unless our interpretation of general relativity is given a significant overhaul, we don't think there will ever be a way to examine what happens inside a black hole. So be alert when someone says they have a hypothesis about what's going on inside. It's just not going to be a valid theory. Theories ought to make assumptions that are testable and falsifiable. The Black Hole Initiative has contributed to several collaborations and papers published and has furthered our understanding of the universe. The picture itself is not the least of these. The image of the event horizon supports many of our current hypotheses regarding black holes. Let's hope we find an anomaly, something odd in the picture of a black hole that we have to think hard to understand. And it's hard to guess what it could be because it's different from what we're anticipating. The most exciting thing about black holes is a feeling of adventure. Go to the unknown and discover something that nobody ever thought of. As is often the case in frontier science, we don't have all the questions, let alone the answers. Black holes test the limits of our understanding, and we have a lot more to learn. Thanks for joining us. We hope you found this video interesting. If so, take a look at some of our other videos you see on the screen now. Also, ring that bell to keep up with new content that we publish weekly. We'll see you next time, here on Solarium.